Our planet doesn't just spin like a basketball on a finger. It wobbles like it's dancing, nods like it's saying yes, and even sways side to side while racing around the sun in a giant oval orbit. These crazy moves control our seasons, change our climate, and even shaped history. And there are three Kepler's laws that explain Earth's motions as well. By the end of this video, you'll know exactly how Earth moves through space and why it matters to every single one of us.
The Earth has two main motions. It spins on its axis, that's rotation, and it travels around the Sun, that's revolution. The 23 hours and 56 minutes is the time it takes for Earth to spin once relative to the distant stars. Scientists call this a sidereal day. Imagine you're spinning like a top while walking forward around a track. To face exactly the same spot on the track, you need to spin a little more than one full turn. That extra spin is like the nearly 4 extra minutes Earth takes to face the Sun again. That's our familiar 24-hour solar day. Earth is also tilted on its axis by about 23.5 degrees. This tilt means different parts of the planet get more sunlight at different times of the year, creating our seasons. When your side of Earth leans towards the Sun, it's summer. When it leans away, it's winter. Earth's spin also creates something called the Coriolis effect, which makes winds swirl and ocean currents curve, a big part of why we have weather patterns and storms. And because of Earth's fast spinning, it's slightly wider at the equator, kind of like how a spinning top bulges in the middle. Finally, over thousands of years, Earth's axis wobbles slowly, a movement called precession. This wobble changes the positions of stars we see, but don't worry, it's super slow, so your lifetime won't feel the difference. In case you're curious, it's about 26,000 years. So, the reason for the almost 4-minute difference between the sidereal and solar day is because Earth is spinning and moving around the Sun at the same time. It's this beautiful cosmic dance that gives us our days, nights, and seasons. Pretty amazing, right?
Nutation, the Earth's nod.
Let's start with nutation. Imagine the Earth nodding its head up and down as it spins. Nutation is a short-term, small oscillation of Earth's axis, like a little wiggle superimposed on the slower precession, that big, slow wobble of the Earth's axis. Why does this happen? It's thanks to the gravitational pull of the Moon tugging at Earth's equator, causing our planet's tilt to shift back and forth just a bit every 18.6 years.
Polar motion, sliding axis.
The story doesn't stop there. Earth's axis also shifts slightly with respect to the solid crust underneath. Earth's poles aren't stuck in place. They move by a few meters every year. This polar motion is mainly caused by movements inside the planet, the Chandler wobble, about every 14 months, and free core nutation, a jiggling caused by the Earth's liquid core sloshing around. These movements are tiny but real, tracked by scientists using super precise instruments.
Milankovitch cycles, Ice Age time machines.
Zooming out, there's an even grander cycle affecting our climate, the Milankovitch cycles. These are three big patterns. Eccentricity, the shape of Earth's orbit, changes from nearly circular to more stretched out about every 100,000 years. Axial tilt, or obliquity. Earth's tilt swings from about 22 degrees to 24.5 degrees over 41,000 years. Imagine Earth leaning more or less. Precession. Earth's axis slowly traces a circle like a spinning top, completing a loop about every 26,000 years. Each cycle alone is subtle, but together they alter how much sunlight reaches different parts of our planet, especially at high latitudes and in summer. Over tens of thousands to hundreds of thousands of years, these cycles change Earth's climate. When these cycles line up just right, ice sheets grow, seas freeze, and the planet enters an ice age. When they shift again, things warm up. Kepler's laws are three important rules that describe how planets move around the Sun. These laws help us understand the way our solar system works, but let's focus it on the Earth.
Kepler's first law, the law of orbits.
This law tells us that Earth doesn't move in perfect circles around the Sun. Instead, Earth travels in an ellipse, which is like an oval shape. The Sun is located at one of the two special points inside this oval called foci. This means sometimes Earth is closer to the Sun, called perihelion, and sometimes it is farther away, called aphelion.
Kepler's second law, the law of equal areas.
Imagine drawing a line from the Earth to the Sun while Earth moves along its orbit. Kepler's second law states that this line sweeps out areas that are equal for equal times. What does this mean? When Earth is closer to the Sun, it moves faster, and when it's farther away, it moves slower. So Earth covers more distance in the same amount of time when it's near the Sun, making its speed change as it moves along the elliptical orbit. Kepler's third law, the law of periods. The third law connects how long it takes Earth to orbit the Sun with how far it is from the Sun. Specifically, the square of the Earth's orbital period, how long it takes to go around once, is proportional to the cube of the average distance from the Sun. In more general terms, planets that are farther from the Sun take much longer to complete one orbit than those close to the Sun. Why are these laws important? Kepler's laws explained the mysteries of planetary motion that early astronomers like Tycho Brahe and Ptolemy couldn't. These laws showed that orbits are elliptical, speeds change, and distances relate closely to orbit times. Also, these laws give us a clear and accurate picture of the beautiful dance planets perform in space.
Thanks for listening to the Wonders of Science channel, where curiosity meets discovery. Stay tuned for more fascinating insights into the mysteries of our world. Keep exploring, and until next time, never stop wondering.